Okay, hi. 5.5, which is the average value of a function. It's our last thing, and it is a breath of fresh air compared to what we were doing. And so I know I have all this eraser going here, and I just want to show you briefly. I wish I would have given more room to show you briefly, and so I'm going to have to write it up here, and I feel bad about that, but I just kind of want to show you what you're finding. So when you're finding the average value of a function, you're finding the average height. And so we have the height, remember, is the distance from the x-axis up to your function. And so I have infinitely many heights, right, on any interval. And so I've drawn, I don't know, 6 or 7 of them there, but there's infinitely many of those heights. And I want to find the average value of those heights. And so how you find the average value of things is you add up all of your data points. So like if you wanted to find the average of your exams, you have had 4 exams so far. And so you would add up your 4 exam scores that you have and you would divide by 4. And so if I'm trying to find the average of these heights, then what I want to do is I want to add up all of these heights and I want to divide by the number of heights. And the number of heights, I don't know if you remember that what we called that, the number of rectangles that we're going to draw, we called that n. Remember back in our Riemann sums? And so if you're looking at this formula and you're thinking, where did the sum of these pieces come from? I just kind of want to show you just a tiny bit of where they came. The integral is an adder upper. It finds the sum of things. And so what I want to find the sum of is all those heights. And so that's what this part is, right? It's adding up not just my 4 exam scores, but infinitely many heights. And then I want to divide by n, is what the number of heights is what I want to do. So this is what I want to have. I want to have the integral, and I'm just being really sloppy here, divided by n. That's what I want to have, right? And so allow me to write this as 1 over n times the integral of f of x, like this. And I know I've left some pieces off, but I'm just wanting to show you just briefly where these parts came from. And so I just kind of put the 1 over the divided by n as 1 over n out in the front. And the reason I want to do that is because I don't know if y'all remember, but I know you do, um, that delta x equaled b minus a divided by n. Do you guys remember that? And delta x was dx, right? And um, and so if I divide by b minus a to the side over here, b minus a, so I put that over there. So I'm dividing by it, right? Cross multiplying, whatever you want to do, but that would cross it out of there if I divide it from this side and make 1 up there. And so that would be 1 over n equals delta x, which is dx, over b minus a. And so that's what 1 over n is. So if I put this in here, instead of 1 over n, I put it's delta x over b minus a. And just being a little rough here, right? And then that delta x, I want to put that right here as dx. And so that's kind of where this 1 over b minus a of f of x dx comes from. So if you're kind of wondering on how that goes, and that's all it's going to do is find the average height of your function. So it says here, find the average value of the function on the given interval. Why I say that these are a little bit easier is because you don't have to, is it a shell? Is it a, whatever have you? Oh, average value. Okay. So the formula for the average value, F average, equals 1 over b minus a from a to b of my function. In this case, my function is called g at t instead of f at x. So g at t dt. And then my a is 1 and my b is 3. So this is 1 over 3 minus 1 from 1 to 3 of t over the square root of 3 plus t squared dt. And then I just have to integrate that. That's 1/2 out in front. And my son has made cookies, and he's not here to give me a cookie. And so he sent a picture of the cookies. And I thought I raised him better than that. I mean, I need to drive and get those cookies. So I can't divide this. And so since I can't divide this, I'm hoping that a u substitution will work. And I want to let u be the inside function. And I have a square root. And so inside the square root is 3 plus t squared. So I'm hoping that that's going to work. And so this is kind of my plan. Whenever I do a u substitution, I do a plan for the u substitution. And so let's see that u equals 3 plus t squared. And then du equals 2t dt. And then du divided by 2t equals dt. That's how I like to write it, but you can do u on that. And then my bounds, I always rewrite my bounds. And so the new bounds, so this is the plan on the bounds. So the lower bound was t equals 1. And now that's going to be for u equals 3 plus 1 squared, which is 4. So that's the lower bound. And the upper bound was t equals 3. That's what we were given. So that would be u equals 3 plus 3 squared, which is 9, 10, 11, 12. Okay, so integrating this, I have 1/2 out in the front. The new bounds are 4 to 12. And I don't care if those turn out in numerical order. Someone was asking me, I haven't had one come out that wasn't in numerical order. I had one come out that wasn't in numerical order in chapter 4, but I don't change them if they don't come out in numerical order unless I'm trying to use geometry to find the integral. But if I'm going to use the antiderivative to find the integral, then just do the up bound minus the low bound, no matter what the size of them are. This one is in numerical order, so no problem. There, I have this t up here in the top. I have the square root of u in the denominator. And I have that dt is du over 2t. And the t's cancel, and if they didn't, I would be like, what am I going to do? And so the t's cancel, and they're gone, and so all I have is u's, which is good. And that 2 that's in the denominator is going to go, it's in the denominator, and I have a 2 already in the denominator. So that's going to make 1/4 out here in the front. So 1/4, the integral from 4 to 12. And you can't integrate something that's in the denominator. So I have 1 over u squared. No, not u squared, square root of u. So that is u to the negative 1/2. And so I have to put the negative 1/2 here, du, and now I have made it where I can integrate it. And so that is going to be, what is it going to be? It's going to be 1/4, and then it's going to be add 1 to the exponent, which makes half, and then divide by half, which is the same as timesing by 2, from 4 to 12. And, that's going to be a nasty answer. And so that is going to be, the square root of 12 is not a nice answer, but the square root of 4 is a nice answer. 2 over 4 is half. So this is half, and then this is going to be the square root of 12 minus the square root of 4, right? Because to the 1/2 is square root. And so, yeah, it's not a nice answer, so that's okay. Life goes on. And so the square root of 12, I got this problem out of your book. Kind of a nasty problem for number 4, though, is 2 square roots of 3 minus 2. And whether you, this is F average, and whether you multiply that together or leave it like that is fine. I think that they actually did, now that I'm remembering, multiply it together in the book. And it is kind of nice if I multiply it together, because 1/2 times 2 is 1. So that's 1 square root of 3. And 1/2 times 2 is 1, so minus 1. So actually it is not much nicer if I multiply that together. Sometimes it really doesn't matter, but I think that on that one it looks a little bit better. Okay, so I did a lovely job on that one. I feel quite happy about it. And what are they asking me to do over here? And fortunately, this one's only 2 pages, and then it's all done, and I'm so happy. And this is the mean value theorem for integrals. It said let f be a continuous function on a to b, and there exists a point c in the interval a to b such that f of c equals f average. And remember what f average equaled, which was 1 over b minus a times the integral of a to b of f of t dt, or f of x dx, whatever you have going there. And so, and then they go on to show you some pictures of it, and they tell you that, and this picture is not very big here, but it's a picture in your book if you wanted to look at it. So f average gives you the average height is what it gives you, and then f at c just tells you where the curve and your average height, this was your average height, where they meet each other. And then you can draw a rectangle from that meeting that you have. And what they're saying is the area of that rectangle right there is the same as the area under this curve. And so that's all that they're saying. And even though that they look a little bit different, but you can kind of see that area up here that would be is kind of goes into that rectangle, so you can kind of see where, oh yeah. So this gives us a chance to do number 12, and they really get a chance to really put on to you the practicing your U sub. And I think I should have had more room here. And so f average is equal the integral of 1 over b minus a, which in this case, this is our a, and this is our b. So this is 2 minus 0 from 0 to 2 of x, the square root of 4 minus x squared dx. And then I have to integrate that, and I have half just coincidentally out in front again. Did I have half out in front before? Because it was 3 take away 1, so it was half, and this is 2 take away 0. So yeah, I did have half on the other one as well, just coincidental. And so if it would have been going from 0 to 63, then I would have had 63 out, 1 over 63 out in front. Okay, so I'm going to have to do a U sub, and I haven't given myself enough room, and I'm really unhappy about that. And so so I'm not going to write my plan. I'm just going to write u equals 4 minus x squared, and then du equals minus 2x dx. And I'm not going to divide that because of my lack of room. Oh yeah, I am. I can't help it. I got to be me. Put a little box around it. Okay, and my bounds I'll do in the margin, just like Fairmont. Is that what is his name? Yeah, in his last theorem, he put it in the margin. So the lower bound is x equals 0, and we have that u equals 4 minus 0 squared, so u equals 4. So that's the lower bound, and the upper bound, I'm having to fit it in the margin because I didn't give myself enough room, because that's how I'm rolling. Or that's how I was rolling when I made this, but I will make a note, and for the real students I have next semester, I will have enough room. X equals 2, I just hope this doesn't come out nasty. So I get u equals 4 minus 2 squared, which is u equals 0. So, so this is gonna all become lovely here, 1/2. The integral, the lower bound was 4, and the upper bound was 0. And that's what I was talking about, is that when that happens, you don't have to do anything. I'm going to use the fundamental theorem of calculus, and so I don't have to switch it. There's no problem there. And I'm going to have x, and then the square root of u, and then I'm going to have du divided by minus 2x, and the x's are going to cancel with one another. So I'm like, hot diggity dog. And then that -2 is going to go out in front and be out there hanging out with the 1/2 that we have. So that's -1/4 out there. When the 2 comes out, it's in the denominator. And I have the integral from 4 to 0 of u to the 1/2 du. And so the -1/4 is holding still. I'm going to add 1, and so that's going to be 3/2, and I'm going to divide by the same darn thing. So this is going to be -1/4, and then this is going to be u to the 3/2, and then times 2/3, and yes, I'm sorry about the room, and this is 4 to 0. And so when I do my upper bound minus my lower bound, so here's going to be my upper bound. I think I will do this part out in front. So -1/4 times 2/3 would be -1/6, right? I'm really tired, so I better check. And my YouTube thing is crashing, and I'm about to scream because I look over there and the last video is not being put up, and I'm like, I'm tired and I want to go to bed. And it's like, it's checking it and acting like it has some copyright kind of thing going. And I'm like, oh my gosh, if that's true, it is -1/6. Okay, and so then the up bound is 0. That's the upper bound, minus the lower bound, which is 4 to the 3/2. So I have -1/6 and -4 to the 3/2 in there. So that's the square root of 4, which is 2 raised, that's -8. And I plan to put it in the calculator. So this is -8/6, which negative times a negative is a positive. So this is 8/6. This is F average. Remember, that's what I'm finding here. And of course, I would never leave it unreduced. No way. 4/3. And I was going to check to make sure that that was equal to 8. And so 4 raised to the 3/2, I'm pretty sure it is. And yeah, it is. Okay, boom, boom. We got that. So F average is 4/3. Then what they want us to do is they want us to find F of C such that that's equal to F average. So we have this right here is F at C. And how on earth did I think all this was going to fit there? Oh my goodness gracious, what was I thinking? Okay, so F average is 4/3. And then F at C is, let's see, it's C times the square root. So I'm just plugging in C where I see X. 4 minus C squared. And then I have to solve that for C. And so in order to solve that for C, what would be the best way for me to solve that for C? Square both sides to get rid of the square root. And, oh man, I feel so unhappy. I was feeling like there's only 2 examples. And then like number 12 and number 4 were like, I had to do a U substitution. And so this is 16/9 and I didn't have enough room. And okay, I'll stop complaining. It's not becoming, my mother says. And so 16/9 equals C squared. I have to square both pieces and then the square root squared. And so, oh, it's actually not going to be that bad to solve. Oh man, I'm going to have to factor it. I'm going to have to whip out the F word and factor it. I think I am. Okay, so this is going to be 16/9 equals 4C squared minus C to the 4th. And it's got degree 4. I'm going to put a line here. So to keep that out of here. So you need 0 on one side, and I would rather have my lead term positive. So I'm going to add that to the other side. So this is going to be C to the 4th on this side. I'm going to take away this, so minus 4C to the 2nd, and I already had 16/9 on this side equals 0. Oh, can I factor that? Well, I have to use the quadratic formula. I don't remember it being that nasty of an answer. It's only number 12. It shouldn't be this nasty. Solving for C is not as easy as one might think here. if I multiply everything through by 9, then that would be 9c to the fourth minus 36c to the second plus 16 equals 0. And then this could be 3c squared times 3c squared. And this could be 4 times 4. And, oh man, that will be 24 in the center and not, because it would be 12 and another 12 and not 36. Really, am I going to have to use the quadratic formula? I hate this example. Solving for C shouldn't have to be so rough. Okay. But then to use the quadratic formula, I really need to use a substitution to show that it's okay to use the quadratic formula. And in this little tiny space, how did I fit that in that last semester? Is there something else that would make that factor? So that definitely didn't. I was hoping it would. I'm getting my calculator. I have a calculator that will do the quadratic formula. Okay, I'm going to have to do the quadratic formula on a different piece of paper. I'm going to let a different variable b equals c squared, so that I have 9cb, not b, b to the second minus 36b plus 16 equals 0, so that I can prove to you that I'm okay to use the quadratic formula. And a equals 9, b equals negative 36, and c equals 16. So the quadratic formula, x equals, so that's opposite of b, which would be 36, plus or minus the square root of 36 squared, are you kidding me, minus 4 times 9 times negative 6 times 16, that might not even be real, divided by, but it guaranteed that there was this, it was guaranteed, so it should be true, so over 18. And so let's see here, 36 squared minus 4 times 9 times 16, don't be negative, it's not. So x equals 36 plus or minus the square root of 720 over 18. I don't remember doing this problem last semester. I mean, I would have remembered this, wouldn't I have? You did have to use the quadratic formula to solve it. Man, it's nasty too. X equals 12. I just took the square root of 720 there. And I'm not on the paper at all. So here I am using the quadratic formula. I have the square root of 720. I'm feeling sorry for myself. If you're not feeling sorry for yourself, then just go ahead and feel sorry for yourself. 12 square roots of 5. I'll have to make sure that I don't pick one out of the book, because this one got, of course, I was trying to pick one where you had to do a U substitution so we could practice the U substitution, and then they asked us to do all this. And I'm like, oh my gosh. Okay, so I'm putting this in my calculator just to reduce it. I lost my minus. And so fraction 36 plus 12 square roots of 5. Maybe I made a mistake when I wrote down the problem when I typed it. Boy, I'm wondering. And so this is 6 plus or minus 2 square roots of 5 over 3. And that wasn't really x, that was really b. And then b equaled c squared, so this is c squared, which is what we were trying to solve for, is 6 plus or minus 2 square roots of 5 over 3. So that c equals plus or minus the square root of a square root. And we want this only to be in the interval 0 to 2. And so I think the negative one will be negative. So we know that it has to be just positive. C equals the square root of 6 plus 2 square roots of 5 over 3, or C equals the square root of 6 minus 2 square roots of 5 over 3. That got really hard. And so this was really hard to solve for C. And so I got to make one that's easier than that, but it was one in your book. And so I'm going to put this in and just see if it's a number between 0 and 2. And so I already have that in. And so I want to take the square root of the answer. And so this is C equals 1.868. It probably told me where to round if I read it, but I don't think I did. And so, and then let's see if this one's between 0 and 2. And so it's the square root. And then underneath that square root, I have 6 minus 2 square roots of 5 divided by 3, which is, it's also 0.0714. So I found those values of C. I didn't have enough room there. I was like, you know, have mercy. I had to go on and do a different piece of paper. So C equals 1.868, or C equals 0.714. And then they want me to draw this. And so I'm going to attempt to draw at least one of them, but I'm going to have to use, it says sketch the graph of the rectangle whose area is the same as the graph under the, sketch the graph of F and a rectangle whose area is the same as the area under the graph of F. Use Desmos. Oh, and you can't even see what I'm reading because I don't know why my camera's gotten over there, why that's over here. Okay, so I'm going to use Desmos. And my YouTube is stuck in some kind of a loop. I'll have to crash that computer and try again. Okay. I should have done this problem beforehand. We're going to do one at a time. X equals, so our C value is 1.8. 1.868, and we want this to be going just above 0. So X is greater than 0, and you use a semicolon, is that right? Yeah, that's right. Okay. So I just graphed that one, and I put the point C on there. So there's the point C on there. And so the rectangle that they're talking about would have a height that is 1.33. So I'll just put that on here, right here. Y equals 1.33. And so now this rectangle that I have right here, that rectangle that, oh, I can make this bigger, brighter, and then how do I get that off of there? I know I'm a boomer because that's all the only way that I can put this on the screen. And then this rectangle that I have here, that rectangle that I have here that's going here from that height there, from 0 to 2, has the same area as the area underneath that curve. That's what they're telling me. And then they're saying that there's another place that happens, and that's at C equals 0.7. 0.714. And you can see that that's at the same height on that curve there. So that's the reason. And the rectangle is still going. And so this blue line that I've drawn in there is not an edge of the rectangle. The edge of the rectangle goes from 0 up to that green line that's going through there, all the way over to 2, and then straight down is where it goes. And then, so it's the same rectangle. And so, of course, it would have the same height. So there's 2 places on the curve that create that rectangle, and they were freaking hard to find, too. And anyway, so that's kind of what we found on there. And so I can definitely do just a lovely sketch right here in my spot, right? So this is going from 0 to 2, and it's kind of up here like this. And then the rectangle is here and here at that same height. And so, and this is the rectangle that they're talking about. So here's the rectangle, and then there's the curve. Anyway, okay, so we did a lovely job on that. No, I would definitely not ask one like that, but it was number 12. Good golly. Okay, that's the end of this video. Makes me feel like I need to go and make sure that I have the right answer and do something about my crash YouTube. Okay, bye.